So today we're going to go through the current Nearpod lesson that I've created for my flipped classroom. To start with, the purpose of this lesson is to kind of look into some key vocabulary words before they start the lesson itself, or start the project-based, problem-based lesson. So we will be beginning with probably about 2 days prior to the lesson. I'm going to give this as homework. In their Schoology, they can have a link that they can click on, or they can have a code. So I've already created the Whirligig lesson, as you can see here. When I create it, I can do a student pace, which means the students can go ahead and go through the Nearpod on their own. The live pace is where I kind of direct it in a live lesson. Since this is a flipped classroom, I wanted to get them this portion of their lesson prior to coming into the classroom. So I click on student paste. It will go ahead and give you a 5 simple letter code that you can use. The students can use this code on any device, so they don't need their iPads. If they do have their iPads, that's wonderful. There's an app. If they don't have the app loaded, they can then go on to Schoology and onto nearpod.com, or they can link it through Schoology, or they can go onto a computer, any devices. So if students have struggles with getting onto technology, it's nice because then they can have an opportunity to go on any devices, even their phone. So it helps with a lot of that, do I have the technology? They don't have to have a certain app. So you put the code in. I always still put this on my smartboard if I am using Nearpod. In this case, it obviously won't be on there. But then this will direct me to the lesson itself. I will go ahead and put my name in. Then I always have the kids put their core in because there's several different classes. I do give each core their own session so I can look at just that core, their understanding, and kind of let me direct the instruction for each specific core, and of course then each specific student. The students will join their lesson. So this video takes approximately about 6 minutes to complete, depending on how long you go through and answer the questions. So there's the interactive part. And so looking at this, the students will see an audio, and I'm not going to click on all the audio. When you view this yourself, you can kind of have each of the audio parts there and listen to them. But this audio just compares the demo that I'm going to do, explaining the 1 coffee filter versus 7 coffee filters and what I'm trying to get out of that demonstration. The students will make their prediction of what they think is going to happen and kind of explain it. This prediction will send me to a report that I will show you momentarily. I did do this in a student pace my own, and you can see the reports that I will get sent to me. And then the student will then watch the video, see what actually happens in the demonstration. And then the nice part is then the students will actually draw what happened and kind of describe the forces. They do have prior knowledge of this. So we have talked about push and pull. We have talked about looking at gravity. We have used the word mass before. We have used the word matter before. But we haven't used it in the terms of how things fall. We've used all of these different words, and we've talked about forces, a push and a pull forces. So they have this prior knowledge going in there. We have used arrows before, so none of this is new. It's just now we're kind of directing that knowledge somewhere else. But so they should be able to use some of those vocabulary words and draw it. So I actually want them to draw both the 1 coffee filter and the 7 coffee filters, and kind of make that distinction and drawing what each looks like and some of the forces they think is upon it. Kind of another way to explain their thinking and to why one of them fell first. So that's kind of what I'm looking at there. Then the next one is comparing the 7 coffee filters that are stacked to 7 spread out, and that's kind of getting our gears to the word surface area. They have heard of surface area. They generally hear it in the forms of math. When I've done this lesson before, a lot of students don't say particularly the word surface area, but they'll just say it's more spread out is generally the kind of word. Since it's more spread out, it then gets more of the air as a common thought process for that. So then they make their predictions again. And then those predictions, once again, I'll be able to show you how I'm able to do it. So this predictions is their thoughts and the ideas. And the key part of this Nearpod and why I'm doing this as part of my flipped classroom, why I want them to do this prior to coming into the classroom, is the fact that I want to see their prior knowledge. A lot of times students will go ahead and need more thinking time to think of their prior knowledge and what they think is happening. And a lot of the times in the classroom, you don't have that time to give them. You give everyone about the same 2 to 3 minutes, because then you have other students ready to move on, and all it is a prediction. So you're like, oh, I want to get to the lesson itself. This allows for students to think of their prediction really in-depthly, and then also think without the persuasion of other students, without looking at the other person's screen or their pictures or whatever it may be. They kind of really think about it on their own and not have that fear like, oh, I'm going to have the wrong prediction. Really have that comfortability with the science knowledge and at their own pace. So another reason that, and I can see their prior knowledge before they come in classroom. So a lot of times with these predictions, I'm not able to. I have to go immediately to look through it maybe quickly and not really look in depthly, and then not having a lot of time to change my instruction and being as prepared because I'm doing it as I'm seeing it right then and there. Not that I can't, but it's definitely nicer to see it the morning before, at least. Then this has a second demonstration where they actually see it. The other key part of this is they see me doing it. It's not someone else. I think when I've done other things, they're like, oh, I heard Miss Fennessy on my Schoology, or they will start going through my Miss Fennessy's YouTube channel and they start viewing videos of there because they're like, oh, you have a YouTube channel? And it's just the idea that it's myself and not just some other person, and it's more interactive and really looking at the teaching, having my voice. So not being that blah, and it doesn't always, a lot of times when you do other videos, it's not exactly what you're looking for. It's always missing that component or that connection. This is exactly what I'm looking for here. And then once again, they have their drawing that they're going to do. So it's a very short, not very long, but it's interactive. So they're not just listening. They have a chance to draw as well. And a lot of times when I do the drawing piece in the classroom, the kids want to draw for another 10 minutes and they really will create amazing ideas, but I can't give them 10 more minutes. Even though this can only take 6 minutes, if the kids want to take 4 more minutes to draw, they have that opportunity, which they wouldn't have in the classroom because we're kind of moving on to that point. So that's kind of the Nearpod. And then it goes to the end and it's not very long. And what is nice is when I go to look at my Nearpod, I can then look at you click on this and you can look at reports. And they should have one report of myself using this and how many students have used it at what time. So when you see a student using it at 10:30 at night, you're like, you were waiting, or will they do it at 7 o'clock in the morning and it was due at 7:30? So those kind of things. So you can actually see the time. And then when you load it up there, you are able to see the participation. And I did answer some of them, so it must be looking at the one that I have right now and not the one I did before. So you can see if there's any quizzes. If I did it, I did the open-ended. It shows me the summary, the draw it, so I will be able to see each of the drawings, and I will see all the drawings of the students. It's pretty neat. And matching up in collaboration. So you'll be able to have a summary of them. And they also send it to you as a homework thing, which is pretty cool too. So they'll send you a little email and saying, oh, this many students have done it. And I'm going to look because I know I did a presentation already and I don't know why it's not showing up. But you can look at each one and it shows you a little report. So it must be this one that I did. Yes, this is it. So then I have 100% of them answered. And then you can actually see my drawings that I have done for these questions. So, and they could all line up there, and you'll be able to look at each individual student. And you'll see how many students actually complete each question. It gives you an opportunity to make sure that everyone is doing it that they're supposed to. Gives you a list of everyone that's doing it. And then this kind of goes down, and then did they complete the open-ended questions? Did they complete the draw questions? There's 100% participation for that activity. So it allows you to see it. And then the nice part is I can, if I'm running this as a teacher mode, as a live mode, the next day I can run this as a live mode and I can actually bring up that picture that another student put up, so they can say, hey, well, this is a prediction someone else had, or this is what someone else had seen, so the other students can see that and view it. So it's kind of the Nearpod. Then I go into what my key part of my lesson. So I really looked at this as being a previewing. I know a lot of times, especially in special ed, giving that previewing or that prior knowledge, giving something to work off of to teach the words. So a lot of times students don't have those experiences. I just now gave them those experiences, and then now they can use the experiences to kind of take it to the next level. So the next part of my lesson will actually be in Smart Notebook. So looking at Smart Notebook, I'm looking at the standards, and the kind of the goal of the activity is for them to, look at each object, see how the mass and surface area affects the falling motion. And a huge part of this is the engineering design too. So that was the main standard that we're kind of working on, is them learning their engineering design skills there. So then the part that's neat is the next day, I will go ahead and have the one coffee filter versus the stack coffee filter, and I will actually be doing it again in front of the class. But before I do it again, I'll bring up the view predictions that the students had. I will complete the demo, and then we'll have that discussion, like what happened here, and bring out those vocabulary words. They might not have done it in the Nearpod itself, but they've already had a chance to think about it. And a lot of times the kids won't say air resistance, but they'll say air is going against it. And just continuing on with those scientific discussions and really getting those key words in there. And once we get those key words in there, then kind of say, oh, well, that's called this, or this is the reason why. So we have that explanation, we have that discussion, and then we do come and get out of there some key things that I want them to come at the end. So at the end, I want these key summary parts to come in. That mass is the matter of an object. Adding mass to an object increases the force of gravity that Earth exerts on the object. Adding mass to the object will go faster the amount of times for an object to fall. So since it has more gravity, it's then going to go faster. So they still end up getting these key terms, but they have an example to go with. So they actually come up with it. Sometimes they say the word mass, sometimes they just say weight, but they know that there's the concept behind it. I just sometimes have to give them the word that goes with it. Then the next thing is doing the 7 coffee filters versus the stack. So once again, we'll review the predictions, complete the demo again. They can kind of see it. They explain, and sometimes at this point I then allow students to give me other demonstrations that they want to do. Sometimes they want to do the 1 coffee filter versus the 7, and then we kind of play with different ones and kind of talk each time about what's contributing to one being slower or faster than the other. And the key part to this is, if I left it the lesson there, I feel like a lot of students wouldn't do it. But there's a whole reasoning that they need to learn about air resistance, that they need to learn about mass. And then when I get into the next part, really goes into why. So once again, I do the summary where there's the surface area, what is it, air resistance, and the main concepts in there. So air resistance is the opposing force that resists of the movement. Increasing surface area will increase air resistance. So they have these key terms, and it's not that I just threw tons of vocabulary at them and told them to read it. So instead, I could have just made this as notes and wrote these notes down to them, but they had an experience beforehand, and they had a chance to do that prediction and all of that stuff before. When I have taught this lesson, could have been at least 20 minutes of my class time. So I've saved at least 20 minutes and also have better thinking process than I would have done if I just did it in the classroom itself. So there was a main purpose. So the huge thing that I have discovered is then after that I have like a little monster quiz. The kids love this game. So it's another interactive thing. They go onto their iPad, they put in this class code, and when I start the game, then I don't have anybody in right now, but when they come in, they'll take like 24 kids, and I can split them up to 7, 2, whatever it may be. And then there's quick multiple choice questions that come up. And then when the kids answer the multiple choice questions, after that, then if they get it right, they will move on to the next one. And then at the end, when they go through all of them, any of them they get wrong, they have to go back to. And it's about speed and knowledge. So just like there's some basic multiple choice questions, make sure they have the kind of idea of air resistance, nothing too complicated, to just reinforce some of the thoughts before we move on to the next part. The key to me, I feel, in order for any flipped classroom is for them to realize that we're teaching these key vocabulary words, that we're starting some of the work at home to then get to more of the important work at school. That there's a engaging problem-based activity to do at school. If I came and then started a whole note lesson and that's what they had to do, they would never complete the video at home because they don't find the need to do it. A huge component that I started doing, because I've done several flipped classrooms, is I make it so, oh my gosh, I want to get this done, and the students always discover, I always struggle on the first flipped classroom activity, and then they discover that there's a reasoning for it, and especially if they're not familiar with it, and then as I go along, it becomes easier and more willing to do it than before. I think a lot of times before, though, my flipped classrooms were still a little bit longer. I really worked on the shortening. So in this case, the students will use that knowledge to build a whirligig, and the whirligig is to be the slowest possible. So they have to look at air resistance and mass. But it's not just, oh, I'm going to make it longer. So they're going to be like, oh, well, I'm going to make the blades as long as I can possibly do. And then they discover, ooh, well, then at the same time, I'm adding mass. So I have to still figure out, ooh, I have to have a middle ground. There's really still two pieces of factors that you have to think about at all time. And they continuously drop it and they redo the design, and at the end, you kind of have a little competition and each student drops their whirligig that they have created and they find out which one's the slowest. Some huge assessment pieces that come with this is I have the Nearpod itself that gives me an idea about the predictions and then what they saw in the video. The other assessment piece that we have is the monster game. It kind of lets me know their thoughts and I can see that as well. And I can also then see the whirligig itself that they created. So when I'm looking at their whirligig and when they are going to come up to their classmates and explain their whirligig and why they different components before we test it, that's another assessment to see, do they really understand the concepts that we were trying to teach. And at the end, they will have a written CER why they think they're, in order to present theirs, they will write a official CR why theirs is the best, why they pick those components, and then they'll explain that in their presentation that they will create. The presentation is going to be in different realms, however they want to present their ideas. I know some students get very nervous about presenting their ideas right in front of the entire class right in there, so they can make a video prior to that explains everything. They can do a Google slide that shows everything, and then they have an audio that goes with it. They can make their own Nearpod, like whatever way they want to present their ideas in the classroom, and then we'll be testing it and then timing each one to see which one's the best. So they also are learning some key engineering things about procedures and about design elements and criteria and constraints. And essentially this whirligig is a simple way to take those ideas, but they're still learning the science. So they are seeing the importance of what air resistance does and surface area and all those things, and then it impacts them to their next challenge. Their next challenge is looking at parachutes and the importance of the parachute. So, and all of those different things going into it has a next portion. So when they get into parachutes, they will learn some of that. They can use those same concepts with it as well. So overall, this is my flipped classroom video. I have learned a lot about really using the flipped classroom as not the teaching tool, but a pre-teaching, reteaching, prior knowledge tool that I've never used before. And I think as I really have learned more about the pedagogy of it than I have had before. Thank you.